If you've ever worked with data, you've definitely heard of SQL joins. They are the absolute backbone of pretty much any data analysis. But let's be honest, they can also be a huge source of confusion. So today, we're going to change that. We're going to make them simple. Forget the complicated code for a second. We're just going to think about building bridges.
I really want you to keep this idea in your head as we go through this. Just imagine all your different pieces of data are their own separate islands. You've got your customer list on one island, your order histories on another. Now on their own, they're useful, for sure. But their real power, the magic, it's unlocked when you connect them. And that connection, well, that's the bridge. That's what a join is.
So you might be wondering, why are our tables islands in the first place, right? Why not just have one gigantic spreadsheet with absolutely everything? Well, the answer is a really core database principle, keeping data organized and efficient. We keep related data in separate, tidy tables to avoid a ton of repetition and just, stay organized. So our job as data people is to build the bridges to bring it all together whenever we need to. Let's make this super simple. Imagine you've got two notebooks. The first one, just a list of student names. The second one has a list of exam marks, but it only has student ID numbers next to them. Now, if you want to know how Amit did on his exam, you have to look him up in that first notebook, find his ID number, and then use that ID to find a score in the second notebook. That little mental act you just did of connecting those two pieces of information, that is exactly what a join does in SQL.
All right, let's get our tools out and start building our first and by far the most common type of bridge, the inner join. You can think of this as the sturdy, reliable stone arch bridge of the data world. Seriously, it's the one you're going to be using probably 90% of the time. And this slide just breaks it down perfectly. I love the kid version. If a student has a perfect match in both the names list and the classes list, they get to cross the bridge. If they're in one but not the other, sorry, they get left behind. The professional version says the exact same thing with, slightly fancier words. Same idea, just different vocabulary. Okay, so here are our two data islands. On the left, you've got the students table with Amit, Ria, and Karan. Now pay close attention to Karan. Notice his class ID is null. That's just the database way of saying empty or no value here. And on the right, you've got our classes table. Our mission is to connect each student's name to their class name. And this is what the instruction to build that bridge, the actual SQL query, looks like. Now, don't worry about memorizing all the syntax right now. The crucial part, the real blueprint for our bridge, is that very last line, on s.classid equals c.classid. This is our one simple rule. It tells the database, connect a student to a class only if their class IDs are an exact match.
And here it is, the result. Our bridge is built. Amit is connected to maths, Ria is connected to science, but wait a minute. Where's Karan? He's gone, because his class ID was null. He didn't have that perfect match in the classes table, so the inner join just dropped him. This is the absolute key behavior of an inner join to remember. It's all about perfect matches.
But what if you wanted to see Karan? What if you needed a list of all your students, regardless of whether they're signed up for a class yet? Well, that's when you need a totally different kind of bridge, and that brings us to the world of outer joins. The most popular type of outer join, by a long shot, is the left join. And the rule for it is incredibly simple. You keep every single row from the first, or left, table you mention in your code. If you find a match in the right table, awesome, bring that data over. If not, no big deal, just put a null in its place. The key is, no one from that first table gets thrown away. So let's see it in action. We run a left join on our tables, and look at that. Karen is back in our results. Now, since he didn't have a match in class, the class name for him is just no. And this just brilliantly shows the difference. An inner join is for finding only the intersection of your data. A left join is for enriching one data set with info from another, without losing anybody from that first group. Now, the left join has a couple of siblings. A right join does the exact opposite. It keeps everything from the second or right table. But here's a little pro tip for you. Most data analysts just stick with left joins and simply swap the order of their tables if they need to. It just keeps the code more consistent and way easier to read. And finally, there's the full outer join, which keeps everything from both tables, matching up where it can and just putting nulls everywhere else. It's a fantastic tool when you need to compare two lists and find all the mismatches. Okay, so far our bridges have been pretty safe and predictable. But there are a couple of join types out there that are incredibly powerful, but if you're not careful, man, they can cause some serious problems. So first up is the cross join. The concept sounds friendly enough, doesn't it? Everyone meets everyone. It literally takes every single row from your first table and pairs it up with every single row from your second table.
It creates every possible combination.
So what's the danger? This, a giant number. Let's say you have a table with 1,000 students and another with 100 classes. If you do a cross-join on them, you don't get 1,000 rows back. No, you get 1,000 times 100, 100,000 rows. This is what's called a Cartesian product, and it is the fastest way I know to accidentally crash your program by creating a massive and usually totally useless dataset.
The other join to be really wary of is the natural join. It seems convenient at first. You just type natural join, and the database tries to guess which columns to connect, just based on them having the same name. But this is a trap. It completely hides the logic, which makes your code almost impossible for other people to understand. And what's worse, if someone renames a column down the road, your query could break silently, or even worse, it could start joining on the wrong columns and give you bad data without a single warning. Just avoid it.
Okay, so we know the different types of bridges now. The good, the reliable, and the downright dangerous. So let's talk about how to build them like a pro. And more importantly, what to do when things go wrong.
I can guarantee that every single person who works with data has shouted this question at their screen. You join two tables that you think are simple, you hit run, and suddenly your result has millions and millions of rows. It's the classic symptom of a bad join. So how do you figure it out?
Here is a simple, foolproof strategy. First, please do not try to join 5 tables all at once. Add them in one by one. After each new join, check the row count. Did it stay about the same? Did it suddenly explode? The moment it goes crazy, you've found your problem join. And the most likely cause is that the key you're joining on has duplicate values in it, which is basically creating a mini accidental cross join.
And here's one final pro tip for you. And this can often prevent those row explosions from ever happening. Sometimes, you don't actually need to bring back data from the other table. You just need to ask a simple yes or no question, like, does a match for this student even exist in the other table? For that question, using exists is way more efficient. It stops searching as soon as it finds one match, which makes your query faster and a whole lot safer.
So, let's end right where we began. Your data tables are islands, and joins at the bridges that connect them, unlocking incredible insights. But you have to always build your bridges with care, because a well-built bridge connects your world, but a bad join doesn't just build a broken bridge, it causes a flood.